So to find the value of A, which is essentially the amplitude of a graph, you have to find the distance between the midline and the highest or lowest point in a graph. So here the midline is going to be at y equals 2, right here. We know that because it is halfway between the highest and lowest points, which is here at like -1 and here at 5. So the distance between the midline and, let's say, the top, for instance, is 3 units. So the amplitude is 3. So this is a graph of y equals 3 cosine x, which is just the normal graph of y equals cosine x with an amplitude of 3. So the starting point is 0, 3 instead of 0, 1. Now the starting point of our graph is actually 0, 5, which suggests that there's been a vertical shift of +2. Finally, to find b, we'll use the period equation. 2 pi over b is equal to the period, which is, in this case, it's 3. We know this because there are 3 units between 2 crests in a diagram. So from 3 to 6, that's 3. I've just done the algebra here, which has led us to the answer. B is equal to 2 pi over 3. So before I started the questions, I redrew the graph so I could better visualize the side lengths. So c equals 6, b equals 5, a equals 4. To solve part A, I just used the law of cosines, substituting 6 and 4 for the side lengths and solving for cosine of A. This is all the algebra, and here we can see the answer. Cosine A is equal to 3 over 4. And this is just a simplification process. For part B, I used the formula for Pythagorean identities, substituting cosine of A, 9 over 16, what we got from part A. Then I solved for sine A, which ended up being √7 over 4. For part C, I used the equation 1/2 BC sine A to find the area of the triangle. I substituted 5 and 6 for BC and √7 over 4 for sine A, as we found from part B. Then, just solving for the area, I got 15 √7 over 4 centimeters squared. So to solve part A, the first thing I did was to try and find the angle theta, because that's part of the sector area equation. And to find theta, I used the information that our perimeter was 10. And if you think about it, the perimeter is just all the parts like added up. So it's line segment OA, line segment OB, and then arc length AB, which is like this. Now we know that line segment OA and OB are both equal to r, and they're the same, so I just wrote that as 2r. And then the formula for a minor arc length in radians is just equal to theta times r. So that's where all of that comes from. Then it's just simplifying it algebraically until we get theta is equal to 10 over r minus 2. Right, and then finally we plug the value for theta into the sector area equation, so this goes over there. And then when you solve that all out, you get area is equal to 5r minus r squared. To solve part B, I thought of our area as a quadratic equation, so I rewrote this over here. So we could find like values a, b, and c, which is -1, 5, and 0. Since the x-coordinate of the maximum point of a quadratic equation can be found through the equation vertex equals -v over 2a, I just substituted the b and the a to get an answer of 5 over 2. So 5 over 2 is the x value of the vertex, which in our case is equal to r. And just to check, I substituted r back into the area formula, and I got 25 over 4, which should be our answer. So to find the sine of -13 pi over 3, I first tried to visualize which quadrant it lies on in the unit circle by thinking of -13 pi over 3 as a change of 4 pi and then an extra -pi over 3. So from the unit circle from 0 to pi, 4 pi would just be, or -4 pi, would just be 2 full circles, bringing us like back right to where we started, and then an additional change of -pi over 3. So it would be in quadrant number 4. So based on our reference angle, which is pi over 3, we know this because our angle of -13 pi over 3 has a denominator of 3. The value of our expression is √3 over 2. We just need to know if it's positive or negative. And we've already established that our angle is in quadrant 4. The way I think about it is if you plot any points in quadrant 4, your points will have a positive value for x and a negative value for y. And since sine is about the y value, our expression also has a negative value. So the final answer is -3 over 2. The process for figuring out tan 13 pi over 4 is nearly the same. The only difference is because this fraction is a positive one, so when we're trying to find out which quadrant we're in, the rotation is going to be counterclockwise rather than clockwise. And since we're finding tan is just sine over cosine, so to find tan of pi over 4, we just do √2 over 2 divided by √2 over 2 because that's the respective sine and cosine values of pi over 4, which just equates to 1. So this is the angle in standard position over here, and this is the reference angle.